Welcome back. In the first episode, I told you the story of how two prayer-guided random draws revealed the path to a complete mathematical overhaul of the Life Force Experiment Workstation. In this episode, I'm going to walk you through what SHIELD Protocol 12.0 actually does, function by function, and why each piece matters. The workstation draws verses from a tag biblical corpus of over 32,000 entries. Each verse carries binary markers across 11 categories in the pentad and polarity systems. The core question has always been, is the pattern in these drawn verses different from what random chance will produce? SHIELD 12.0 answers that question with 21 new mathematical functions organized across 9 analytical domains. The first domain is Bayesian enrichment analysis. Under the old protocol, we used z-scores with Benjamini-Hochberg correction. The problem is that FDR correction at n equals 100 with 11 markers is brutally conservative. It kills everything except the strongest signal. SHIELD 12.0 replaces that with beta binomial Bayesian posteriors. Here is how it works. For each marker, we set a prior distribution centered on the known corpus baseline rate, with a prior strength that is now automatically estimated using empirical Bayes across all 11 markers. The posterior tells us the probability that the true enrichment rate exceeds the baseline. This is not a binary threshold. It is a continuous probability. An 88% probability of enrichment is meaningful information, even if a z-score of 1.36 looks like noise. We also added ROPE thresholds. ROPE stands for Region of Practical Equivalence. It asks, is the enrichment not just statistically above baseline, but practically meaningful, meaning the rate exceeds 1.5 times the baseline? And we compute likelihood ratios for every marker, expressing the evidence as 4.2 to 1 in favor of signal, which is far more intuitive than a p-value. The second domain is information theory. Shannon entropy tells you whether a draw is focused or scattered across markers. But at n equals 100, raw Shannon entropy is biased downward. SHIELD 12.0 adds the Miller-Maddow bias correction. Renyi entropy at 2 different sensitivity orders. Alpha equals 2 for peak sensitivity and alpha equals 0.5 for tail sensitivity. Normalized entropy on a 0 to 1 scale, effective number of categories, and a bootstrap 95% confidence interval computed from 2,000 resamples. But the real power is in mutual information. The protocol now computes all 55 pairwise mutual information values across your 11 markers. This creates a complete map of which markers co-activate and which are independent. From this matrix, we extract network centrality measures. The hub marker is the one with the highest weighted degree, meaning it co-occurs most broadly. The bridge marker has the highest betweenness centrality, meaning it connects otherwise separate marker clusters. In the original draw that triggered all of this, identity emerged as the hub marker. That makes sense theologically. Identity is the bridge through which inheritance and priesthood flow. The mathematics confirm the theology without anyone telling it to. The third domain is permutation testing. The old protocol ran 10,000 random draws and compared your observed DT3 count against the distribution. SHIELD 12.0 upgrades this in 3 ways. First, the +1 correction. Instead of reporting p equals 0 when no random draw matches yours, we report p equals 1 over 10,001. This avoids false certainty. Second, binomial confidence intervals around the p-value itself. The permutation test is an estimate. The CI tells you how precise that estimate is. Third, and most importantly, genre-stratified permutation testing. If your draw contains 40 narrative verses and 25 prophetic verses, every null draw is now forced to preserve that same genre composition. This isolates the question, is there enrichment beyond what the genre mix alone would explain? The fourth domain is spatial pattern detection. This is entirely new. Under the old protocol, we had a scan statistic and a shilling run length metric. SHIELD 12.0 adds 5 spatial methods. CUSUM change point detection finds the exact position in the verse sequence where marker density shifts. The autocorrelation function tests whether the sequence has memory, meaning does the presence of a marker at one position predict a marker nearby? The Wald-Wolfowitz runs test checks whether the overall ordering is random or structured. Nearest neighbor gap analysis measures the distances between adjacent markers and compares them to what random placement would predict. And one-dimensional Ripley's K function measures clustering at multiple distance scales simultaneously. Every one of these includes permutation-based significance testing. Every one runs in the browser. The fifth domain is the Combined Pentad Signal. This is Fisher's combined probability and Stouffer's z-score method applied to the enriched pentad markers as a group. The question is not whether any individual pentad marker is significant, but whether the pattern of multiple elevated markers is collectively too improbable to be chance. This was the breakthrough that revealed what the old FDR was hiding. The sixth domain is interaction information for the Dominion triad. This decomposes the three-way convergence of identity, inheritance, and priesthood into pairwise effects versus genuine higher-order synergy. A positive value means the triple convergence is more than the sum of its pairs. The seventh domain is genre analysis. The chi-square test for genre distribution was already present, but now we have the infrastructure for genre-adjusted baselines and composition inflation metrics. If your draw oversamples from apocalyptic texts, which naturally have high marker density, the protocol can now separate that composition effect from genuine within genre enrichment. The eighth domain is the verdict system. The workstation's deterministic inquiry module already produces probabilities for yes, no, and unresolved. Shield 12.0 adds Dempster-Shafer evidence theory for representing ignorance explicitly and a decision-theoretic framework with explicit loss functions. Instead of arbitrary confidence thresholds, the protocol asks, what is the cost of a wrong verdict, and which declaration minimizes expected loss? The ninth and final domain is the composite draw score. This is no longer a hand-tuned weighted sum. It is now a 5-component, empirically grounded index. 30% from the DT3 Bayes factor, 25% from the combined pentad signal, 20% from the average pentad posterior probability, 15% from the interaction information synergy measure, and 10% from the spatial pattern detection results. The score runs from 0 to 100. It carries its own internal validation, and it needs no AI to interpret. A score of 72 with a strong signal label means exactly what it says. So here's where we stand. Shield Protocol 12.0 is live. The workstation runs in the browser. 21 functions across 9 domains. Every draw now produces a Bayesian enrichment table, a combined signal analysis, a full mutual information matrix with network centrality, expanded entropy with bootstrap intervals, scan statistics, spatial pattern detection with change points and runs tests and gap analysis, interaction information, stratified permutation testing, and a composite score. The draw asks for mathematics that could interpret itself. Shield 12.0 is the answer. This is Dallas James, Hearts 2 Fathers Publishing. The data speaks. We listen.